It's a great pleasure to present to you a symphony of screens, coordinating Java microservice for complexity and precision. My name is Howard Denise. I'm the founder of Stream Code for J. This is a tool so easy to totally data orchestration here. I will show to you in this presentation. But before of everything, I just like to thank you too much. The Elson organization. It's a great pleasure to stay here and presenting to you. I said before, the orchestration of data and the orchestration concept, we can compare the orchestration as the data workflow of Symphony, also orchestra Symphony. Well, the Symphony orchestra that has when you talk about many components working together to provide a cohesive outcome, and when you have the symphony orchestra with a computer, we have the data workflow, the orchestration, and how the symphony orchestra, the conductor, ensure that the musicians play nicely to what the music playing in harmony. That the orchestrator in that workflow, data workflow, just like is smoothly and result in the pipelines. And then, well, when you talk about it, so how the musicians or data tests working following the conductor instruction in our case the orchestrator scale and then must move to a specific instrument for the administration wire. Yeah, it can do all the workflow with our API library. But well, I will just show to you again. And well, and so it improves the efficiency, enabling teams to derive meaningful insights from their data swiftly, effectively. And it's the very important importance of orchestration, data orchestration for data engineering teams is in summary just complex management, and so the quality and scalability, time efficiency, and collaboration. And the orchestration benefits can highlight the workflow management and regarding centralizing control, refined the platform to manage the data workflow, task scaling, it allows scaling task in specific teams or events and at times or events, and that is tracking or management of dependence between plans, ensuring that the data is processed in the correct sequence. Another thing that you can highlight is automation. You do reduce the manual effort because you are just automating repetitive tasks and increasing speed because we speed up data processing and helps respond to quickly the new data insights or business needed. And consistency, of course, to make workflows using the likelihood and human error and the participation of you in this process is decreased in variation process execution of the. And I hope in a way to I like to because I have built in one foreign and it's typically including monitoring tools and that provide when the real-time insights into workflows performance and enabling quick identification when issues. You just realize that when I showed to you that this is one of the main features of streaming social data and so to review automatic it tries they can automatically try the same task based on defining rules and missing downtime and manual query efforts, alerts and notifications. Users can receive alerts for failure or anomalies in the workflow and facilitating projects and intervention in resolutions. And another talk that you can just on the feature you can just highlight is resource optimization, the effect efficient of resource allocation, which is you optimize the use of computational resource by distributing workloads appropriately and preventing residues, bottlenecks, and cost management. Cost management so by optimizing resource we use of using um, use it by our organizations can just reduce the costs associated with cloud service and data processing, leading to more efficient operations. And how about because you can provide flexible just uh, flexible conditions to scale the processing and and processing up or processing down which was necessary to ensure that the resource aligned it's aligned to the core deliver them and without overspending. And well, I think that this is the main points about orchestration. In the data orchestration tool that I present to you is developed by me is so easy just to you have all these features that I said by you before on how easy it's easy to coordinate and join microservices for complexity processing and then just using in real time, how I said before. And when I this is from for J and then and how it works, of course, this is our main definition. This 110% open source and it enables real-time data processing, Kafka, Redis, and RabbitMQ. This is a wrap of complexity processing that uses the engine of SRCP and just to remove the complexity. And they provide an infrastructure for Java programmers to handle only the business logic. Everything just abstracted to you. And they just work with the business logic and over the pipelines and the streaming data of Apache Kafka, Redis, and RabbitMQ. And people used to say, just actually what it's recommended, they used to say some good to make a compatible analytics and data motion to enable the analytics on wide amount of real-time data from multiple sources. And so developers to easily create the systems to identify unique and fleeting opportunities that companies should act or within a given time frame. Processing massive data and like should also be big data and all fits so that, and you realize that all the processing, for example, when you use RabbitMQ and Redis, and mainly with Redis, with this resource and user resource real time and putting in parallel and it just and in memory is sort of a memory processing. Let's provide a lot of resource in memory processing, and it's very good to go with big data. You know, facilitate IoT mockups. Actually, I will show to you the practical example here is about some IoT mockups, making some data orchestration and or how they're trying to see this mockup in IoT. And of course, this is all over the event-driven architecture, and how you can just realize the pattern of event-driven architecture as then the producers, consumers, and it's all like a poem. It's all made of this architecture and how the producer make the consumers to be being notified. And more than this, we have our wild here. I'm comparing it with the Symphony orchestration. And this layer here also that I will make the management of all the behaviors in the queries just to provide by a REST API for this layer, and you just change the management and change the resource and change the direction of the destination of the data provided, and in the pipelines of this pipelines can be Kafka, RabbitMQ, or Redis, as I said before. And we have here the stream software just coordinate in the middle of this architecture and just analyzing and just coordinate it and using the admin layer here, like the Symphony architecture, the Symphony architecture. We have the conductor with one, and we have our orchestration stream flow with this administration API that is our that make all the data tasks conducive by these operations. And I think that you will understand more and then how I say this elements, this is the element that you coordinate. This is our one here because when you when you just want to provide some event, uh, this is something very interesting because you can just realize that when you are just working with event architecture, we have events and first of all, you can just define the event and after that just create some behaviors or groups or queries. And this is the tags or the scope of the REST requisition here. This is the scope event create for to create a new event, the scope of addition rule, the scope of edit rule, and the scope of delete some rules. And well, how I say to you, when you use, it's very useful to make data orchestration in common case of data hubs because we have consumers here and the data flows by some pipelines, the data hub, and maybe some pipeline just so proceeding information. And using streaming Flow4j, you can just make the analysis, create some results, and redirect this uh, for these consumers. And and this as we got see this practical example. Imagine some real, how I said before, just some IoT mockup that we just provide here, and just to do you want to create some notifications of contextual data change on the and a given sensor. And well, imagine that you have a filter. You want to have a sensor just captured by maybe some Arduino simulating here, and need to publish, you will be the publisher, then you just need to detect the temperature change. And well, different applications to our subscriber, how I said in our in our slide before, that we have some data hubs and consumers. Our subscriber can be notified by that and adapt the behavior according to the receiving value. And well, um, this is our practical example. I'm just talking about an interior here, but I will show to you everything, all the advantages of use or streaming Flow4j and actually with data orchestrator. And well, let's go. As of our main web page, this is our main web page, and you just go there and you can just see some great information. And if you go there, you know, our main web page is here. This is our main web page. It's how I explained it before to you, how it works, and all the recommendations here. In the end, we have our portable tutorials here in YouTube, our GitHub repository, official repository. If you arrive in this repository, it's here all the code, 100% free for you use, open source. And if you arrive on maybe some service middle for Kafka, for streaming Flow4j for Kafka, do you have all the guidelines here for you follow and just you provide all the information that you need. Um, this is a guidance, but if you have any doubt, you can return here in our official web page. There is my official contact, and there is all the way of you find me, and it will be a pleasure to respond to you. And well, returning here, just you can make the deploy of the code and make it. You can just use Docker and make the building and deployment. And how I did here, it's already here. I made the deployment of system in Flow4j and the REST endpoint. This is our orchestration layer here, administration orchestration layer here. And so using the API like the one as a conductor of Symphony, orchestration Symphony, this is our layer. And when you send the information, you just have the capacity of control and change the behavior. For to help our I already made the building and deployment here, everything, just to not lose time. If you have any doubt, how you can go to our YouTube portal or follow the guideline. And even you still have uh, some doubt, you can just send me an email. It'll be a pleasure to respond. And how to arrive here is you have no experience. It's so easy. And if you have experience, you'll be so fast. You will arrive in this point. And uh, I just put the instrument so far run here. Actually, it's already running here. And for our example here, I create some uh, some consumer here that will listen and and that in that pipelines of Kafka, and it will still reading in the Kafka pipelines. So I just follow how I show it to you before uh, here, and it will just reading in this pipeline of our distribution in our data hub, and you have a listening for each pipeline here: ports, dashboard, heat maps, and interface and prediction. And how you can see here, it's already running, but how it has nothing in any behavior, any result. You just hitting nothing. And well, if you, I just reading and the in the dashboard, and another one is report, and as the same, you not read nothing because there is nothing running, but it is still listing this and this pipelines. And well, we have uh, here the cap drop. I just put here cap drop just to better visualizing the pipelines here, and you can just realize that all the pipelines are here and listen that. So for our example, our simple example, it's just the way how you can manipulate that, create event, update, and create rules, update and delete. And the first thing that we're gonna do, it's just create an event for our application understand. So returning to the presentation here, no, it's just in that point that it was turning. We just represent this example how I said before. After that, and just you know our environment. The first thing that you should to do, it's use this uh, um, this administration layer and send the information, rest information like one and the conductor Symphony, and just saying that, hey, create some event called thermometer. So it is what we're gonna do. It's running. So this is that scope, and we just create this on an ID and just thermometer. Okay. I'll just send that and send this information. It's our sending. It's our sending. It the message sent. Okay, you can check your out here that in the administration layer you can see that the information was passed, and then it returned this information for streaming flow for J here. If you check it out here, let's go to check it out. And it's look, this is the result. It's already it already create the event, but there is no behavior because there is no rule. The second thing that you should do is just create some behavior, and so following the next step should the to create a rule. No, and the same is the same. It's just a change uh, for the types that I present before. Rule create, rule query. I just say that select the temperature uh, from thermometer. We in a window of 5 seconds, and of course, just sending this destination rule query, uh, we're gonna create that in the sense for our listener that you programmed before. And so let's go to create here. If you see the the example here, the real example right now is the select temperature for a thermometer, where the temperature is less than 10, and returning for this listener, no, that we programmed before. Now I show it to you. This spread, it will respond here in this. And sorry, let me just spread, and it will respond that there's 404 here because there is nothing, no, because well, uh, I was, yeah, prediction. I think that's prediction. Okay. Let me just check you out what's the controller that. Okay, prediction. It's dash heat map interface. Okay, prediction. It's here. You you understand. Okay. Okay, it told me nothing because there is nothing in the queue, but you arrive here. We're gonna send this information for streaming flow for J. Let's go to see the result. Okay, we can check you out there again. It's arrived here. Now it's streaming flow for J and create this this new rule, new behavior, select temperature. Okay, and when you see it created um, the ID for this rule. This is very important, and so this is the idea that you after this way just send the behavior of the query. Just to copy paste it here, and the rule update here just to put here because this is uh, another behavior that you're gonna do. So it's you put here just to the next step. Uh, we create the rule. Now we should to send data. You know, because I said for you, it's right now understanding. If you send some information, a thermometer ID and temperature and a file, it will receive this information and send it put there. So let's go to check it out. Okay. Uh, this is the behavior. Okay. Uh, if you check the consumer now and prediction, it should just appear here, just show it here because this is right now it's consumed. Uh, this is in a simple consumer just to show for you. And if you, I just make the update. Of course, it was consumed. It will not appear more because was only one, uh, only one sending. Well, but this is the interesting thing here, no? Because I say that uh, this information should arrive if in our rule that I created first is less than 10. For example, if this is the great thing in the data orchestration, if I send information here that I put not 5 but 15, okay, it will not realize because it just see thermometers with temperature less than 10. So how you can see it processed, if you check your route there, you cannot see nothing because it not respond for our destination. So if I and in another step, I just send, okay, let's go to put not 5 but 7. Okay, I send and you will receive there, making our orchestration, no? Because when it arrived there, the 7 will arrive here just when you can check your route here. And this is the bad thing in this data orchestration. You can control the destination, you can control the behavior. And the next step is just to show the arriving more information. For example, some temperature just over than 10 or over than 15, whatever. We can just change the behavior here. I say that the first behavior was less than 10. Now I will change the behavior, saying that say that to him that, hey, the uh, the behavior now for our just change here because I was making some previous previous tests here. Okay, I just put another copy paste here, but right now you understand that the temperature is over the 10. And in the sense you respond in the heat in the heat the heat listener, no, not more in the here in the prediction. Uh, okay, let me import here. So it and you see, okay, I just turn here just to, I think that's heat map. Okay, okay, heat map, and so heat map. You're gonna see the coordination. Of course, there is nothing here, no, because it not made the change, but we right now gonna do it. So I say that respond in this and change the the destination of the information, and now it consider temperature over 10, no more before 10. Just so it's just I put before I you should realize that I put the ID here of uh, that behavior, that query, and let's go to see that. So it sent that just to check you out. When you see in experiment flow for J, yeah, it made some change here. Let me see. Okay, Okay, it made the the update here, no, and just change it and make the and make the update here, and this is the requisition, and it are considering this this new rule. When you see that, if you just send information that we was changing, how we change, because it's temperature, uh, the temperature is over than 10. Let's go to just send again. And so we just send 7, so it will not receive in any place. If you see that, it should receive before, but right now not. So if you return to the prediction, it will not more receive, and no more receive in the heat map, because 7 it's less than 10. So if we do it and put 17, for example, it will now understand. Okay, if you check it out there, and no more here, of course, because it changed the destination. And of course, it appears here in the heat map. We make the all the mapping, new mapping here. This is the great in this data orchestration, and how it's dynamically dynamically we can do it, and just to redirect the destination, just to change the behavior. And of course, we can just in the end, just to show that we can delete this information here. Uh, it is the same idea. I just copy the idea here and show that nothing more will happen, because um, we gonna just delete this query, and this behavior will not more exist. And so I will delete that. I can see here this is successful. And when you just send more information, the behavior required do not more exist, and will not happen more. Just so I can see, and yeah, will not receive nothing, because of course the queries do not more exist. And if you create or create a new rule, no, and saying returning to the consumer thread, and this is the prediction. This is the 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 consumer that the endpoint that will receive this information, and say, okay, just return or change maybe equals 10, maybe equals 10. So let's go see creating this new query, and it will create this new query, and you can realize here it created the new query, and this is the new ID, the new query. Okay, and just hit in there, and well, just you put here, okay, and just to make the copy paste here, just to make the magic behind of this. But when you send information here again, no, because we start just to uh, put in information. If you send 10 now, it will understand, and of course, you provide that information and the routing, and anyway, if you come here is just here in prediction. It will appear here because I created that. So uh, the behavior change just are considering a temperature 10. And if I put, for example, 20 will not receive because I just changed that. So uh, put 20, you will not, of course, understand. But uh, when you see here, it not represent nothing. But if you again change the behavior, how I show it to you, um, this is the logs are very very important because you can record the ID, you know, and the observability. It's very very important in this sense. And here I say that oh okay, just right now I want to change this and return to heat and and in this heat map, just saying that okay, just the temperature 10 or more values, so over 10, and returning, and we're gonna see that we return just made the behavior and had directed that information here. It cannot see nothing, but right now, if I send it again the 20, how I said I will show it before, it will understand that this value and capturing it direct for the destination, the right destination program. Here we can see we change, just put here, yeah, the heat map. And okay, this is really again here, and this is the magic behind of this. I think that this is a simple example because we can make a lot of great things here. But to not lose more time, because I think that I lose too much time or is time enough. I just want to say that, well, thank you very much.